APIs. I am Ben Edmunds. I do open source work. Alright, open source work. Most known for IOF, which is a auth package for CodeWriter, which is kind of going by the wayside as CodeWriter has lost a lot of, kind of the momentum in the market. I'm also on the CI Council though for CodeWriter, which is the board of directors. So we're working on progressing CodeWriter, making it more modern, bringing it to the forefront of PHP technology. We just released version 3 and we're currently working on version 4. So expect to see some announcements for that in the near future. The author of Building Secure PHP Apps, which is a pretty basic introduction to just secure web development and specifically PHP. Also working on a Node version right now. I do the PHP Town Hall podcast with my buddy Phil Sturgeon. He's that angry British guy you see on Twitter usually. And I'm the CTO of Mindfulware. We do insurance and medical software, mostly using PHP and Node as the tech stack. If you want to catch me on Twitter, on my website, it's Ben Edmunds, no spaces. My website never gets updated, so it's probably pretty boring if you can check that out. Let's get going. Today, I'm going to go really fast because we're 15 minutes behind schedule. If you get lost anywhere, feel free to approach me after, and we'll go through it. What we covered: RESTful API basics, API design, how to implement that API, and then versioning off and labeling. Let's get into the basics here. What is RESTful? What does that mean? It's representational state transfer. It's a way of structuring and architecting an API. It's a pretty loose standard with a lot of different implementations and ideas. So today we're going to be going through my very opinionated version of that. That doesn't mean that it's the Bible, and you're probably going to have some disagreements with me in a lot of ways, and that's perfectly all right. This is just a basic intro with my opinions. A core concept to REST APIs is that you use HTTP methods to define how you communicate with APIs. So instead of, like so, where you're going to tell it what action you're going to take, whether that's creating, updating, deleting, reading, with RESTful, you're going to use the HTTP verb. So the way that you send the request gives you data on how the request should be processed. For example, if you want to read data, we'll do a GET request. We'll get into that more. It's usually very expressive, especially a good RESTful API. So the URLs that you use, the paths that you take, the verbs that you use to communicate, will express to your users what is happening with that data. And we'll show you what that looks like. JSON is probably the most used format for RESTful APIs. In general, though, RESTful APIs should be able to respond with multiple formats. It should look like XML, JSON, anything that you need. And it's just a format layer. The format that you send through, it's inconsequential. We're going to show JSON examples today, though, because that's definitely most popular. JSON looks like this. If you use JavaScript, you are probably pretty familiar with it. It's JavaScript object notation. It's supported natively in most languages, encoding and decoding is permanent. In PHP, you're going to use JSON encode and JSON decode to go in and out from JSON data. It's just going to translate that into a string and then into a PHP array or object, depending on what parameters you pass to the functions. All right, a good API is simple, expressive, and intuitive. Also stable. If you ever use, say, the Facebook API, you know that they change that all the time. So you never know what's going to happen with your data. Your integration constantly breaks, things like that. We're going to come to versioning later, so if you need to change your API, you need to version it. That way, if you're using a certain version of the API, you know it's stable, you know it's not changing, you don't break your usage integrations. An unstable API is pretty useless. It's also consistent, so if you're going to use plurals in one place to reference objects, you should use plurals everywhere. If you're going to use double nested verbs for relations, you should use that everywhere. So if I know that I'm going to get a user with the user's endpoint, I should also know I can get post with the post endpoint, right? So you're going to be consistent throughout, and you should be able to guess what the next item is based on what you need, because it's very consistent. Again, Facebook, if you've ever used it, you know why that makes me sad. So I like to stress, Don't do that. An API is also pretty useful without documentation. As developers, we usually hate to document things because it's so boring compared to just writing some code and seeing stuff happen, right? But without good documentation, your users will struggle, and regardless of how great your API is designed, if people have to struggle to integrate with it, they're not going to like it. I would rather integrate with a pretty crappy API that has good documentation than a beautiful API with no documentation. No one wants to read through your source code to figure out how the API works. API-driven development. The idea behind this is that you're going to write an API for your software. So, and let's say most software, you have an MVC pattern, your model communicates with your database, you're calling the model constantly to interact with data. If you're doing an API on top of that, a lot of times you'll do your whole MVC pattern, you'll get your site worked out, and then later you'll come back around and you'll add an API on top to also interface with the same models, the same data, and expose that to external sources. The idea behind API-driven development, though, is that you run the API first. So you write a layer between your model and everywhere else. Here's not that example. So the APIs will interact with the data. You use that internally and externally. So internally, you're using that API to interact the same way that your external customers are. It's dog fooding. So you know it works well if you use it yourself. You see problems with it. It also gives you one place to do things. So instead of having to support two ways to interact with the same data, you now have one way. It's the same way internally and externally. Status codes are a big thing with APIs. You should be able to tell what went wrong and what went right with your API calls based on the status codes that are returned. It shouldn't just always be a 200 OK and an error inside that. You should return a very expressive response. We'll go through a couple of the basics, and they definitely dig in more. 200s are usually success. 300s are redirects. 400s are errors. So this is usually a client error, so bad data, for example. 500s are service errors, so timeouts, unable to resolve, things like that. Birds. So we have post put, get put, and delete we're going to cover. Post and put are mostly for creating data. Use put if you know all the values, so if it's omnipotent. But if it's not, you're going to use post. So that means you don't know the ID, for instance, or you don't know the GUID that's going to be assigned. You'll just use a post, and that'll be assigned and returned back to you. You know what that is? You can post it. We'll dig into that. Gets it for reading data. If you want to pull a certain user, you can pull a list of users, things like that. You can use the GET request. And then on your API, you can be able to tell, okay, it's a GET request, so they just want to read data, right? It helps you with your logic flow. You know what to do with that data without having to inspect the whole format of the package. And you also know how to authenticate that, because usually you'll have less authentication on, say, a read than you would a write. And it puts identified if you know all the data. Usually that means you know the ID. And you can keep sending that multiple times and get the same exact result when you use put. If you're going to get different results, then you're going to use post. An example of that. So here's an update with put. We have the ID, the first name, and the last name. No matter how many times we send this data through, it's going to be the same exact result. Every piece of data matches that. Deletes are pretty self-explanatory. It's for deleting things. Again, you definitely want some authentication on that. Consistency. Endpoints represent the data that they're associated with. So / user should be your users, your data model. / companies would be companies, right? You would use company for a single item, companies for multiple items. Single objects map to singular URLs. So / user, / the ID, or the GUID, or whatever you're using for your identifier, always matches to a single object. So you know, depending on your structure, either you're getting an object back from this, or you're getting an array, or whatever. Your item is a single item. You're not going to array multiple items. Ideally, you return JSON data, so it can be a single JSON object you return for a singular URL. Plurals map to plural URLs. So users tells you that you're going to get an array of items back. So in this case, a JSON array of multiple objects. So you always know, hey, as users, this will be multiple items. You don't have to try to dig into the data to see what's there. You don't have to comment, anything like that. Users are multiples. You should have common actions across most objects. If you can get a user with user 2, you should also be able to do company with company 2. Right? So if you can do one thing in one place, you should be able to do that elsewhere. That's a lot of times falls through with relations. So we're trying to get the user's companies, so we have user to the company. That can't always translate across, but if it has a relation, you should follow the same object model. Alright, so here let's dig into it a little bit. What does this look like? Statuses map to all the statuses. Could be SQL, could be NoSQL, could just be a flat file, whatever your data source is there. Status, 1, 2, 3, 4, will map to a single object, 1, 2, 3, 4. I know I'm driving that home a lot, but you see this mistake in so many APIs. You can't guess where the URL is going to take you and what kind of data is going to return. It's really bad design. Creating the data, you're going to do a put to status 1, 2, 3, 4. We're going to put here because we know it's 1, 2, 3, 4. We know that ID, so the data is going to be the same every time. That's what it looks like. So we're putting that data, passing the ID, same thing every time. Right? Done all the data, we're going to do a post to API status. It's going to be unique each time. So every time you post that, you're going to get some kind of identifying information that changes every time. So if we get this post call 10 times, our resulting data sets will be 10 unique data sets. Usually that's just the ID. That's what this looks like. So we're doing that, and then we're going to response back with success and then our ID. Success will also be inferred by the fact that you're going to respond. Reading, so your API statuses to read the data. Complex requests, sometimes in additional data. So we have API statuses, and then we need to get, they were retweeted, they were active, whether we need to add additional filters on that. So multiple ways you can do this depending on how you want to design your API. I'm a fan of just queries. You know, you're just throwing on a query program there. It's universal across most languages. You know how to use it. Some people prefer forward slashes and then separating the data. That's your call on how you design it. This is what I would recommend. For updating, again, you can do puts here because you know all the data. Update it. Here we're adding test status 2, and I'm going to run that. It's the same. Deletes, you can either just throw all the data in the URL, or you can also pass data through. I prefer passing data as well, whether or not you do the URL. That way, for example, if you're inspecting the response and you're trying to debug, you have it also in the package. So let's say you're logging when your request is going through, you can pretty easily grab your logs for what's inside that data package, and you can see what ID you're deleting. It's really good for like auditing, not a requirement. The relation should go to the item you want, and then the relation on top of that. So in this case, we're getting status 1, 2, 3, 4. Then we're going to get user associated with that status. Relations, again, can be kind of weird. So let's say we want the user's company for that status. You can imagine this could go pretty deep, and you have to decide how deep you want to go. Usually with a little magic, you can make it go as deep as it needs to. So let's say status 1, 2, 3, 4, user, company, things like that, and just keep building on that. And drill down through that data model. You could also say, okay, so we're only going 2 steps down or 1 step down. And you have to make another call to get user 1, 2, 3, 4. All right, let's go through versioning a little bit here. Each version should have its own routes. We'll also go through another way of doing this, but in this case, it would be V1 and V2 in the route. Then our newest route is just going to be routed through a magic API or a magic route. All right, so in this case, it's api.site.com, and that's going to take you to the newest. If you're using a subdomain or just /API or whatever, that should always just take you to the newest one. If you want to do that, you're going to want to specify the version. That's their choice. Keep in mind, though, if you break that and go to a new version, you really need to let your users know. So they could be using API. Just api.com, right? And then you change that, you go to V5, it's going to break everyone that's using that. Another more preferred way to handle that with RESTful APIs is using HADOS, so we use accept headers. So here we're saying we accept application JSON data, and we want version 4 of the API. This way, your users don't know URLs. We're passing these in the headers, and you read this headed here and you do it. Hypermedia is a core concept of RESTful APIs. And it's not exactly required, but it's definitely recommended. It stands for hypermedia as the engine of application state. So a lot of complex things. Just to say we want content negotiation and hypermedia controls. What does that look like? We're going to tell it what kind of data we accept. So are we doing JSON data, XML data, whatever kind of data we're using, right? We're also going to tell it what kind of data we'll take back. So also we're sending what that looks like is this application XML, application JSON. It's just an HTML header. We'll also do options requests, and this tells us what kind of data we're going to be using. We're going to be doing gets, posts, puts, deletes, whatever. We're going to basically be very explicit about telling your API how you're going to interact with it. And it tells your users, say this endpoint, okay, so they do an options call against /users. Your API returns back the options that it will take. So your users can dynamically say, okay, so users, you can't add to that. You can only read that because this is an object list, right? So you're only going to get back get on that options call. Also, hypermedia controls. What this means is that you want to pass through metadata on your endpoints, on your responses, so that the users can then dynamically infer what comes next. What this looks like is here we're doing basic pagination, really. We're saying users. We have rel equals self. Self is usually an accepted term. You can use whatever you want though for this object. And then we have rel equals user, and that's telling us the user for this object, right? So in this case, we got the user of the status. That way we can dynamically just drill through the links here in the API, and we know our data model. We can map out our data models dynamically based on this, so we can change those later. And if the user's consuming it properly, it automatically updates. Also related content, especially errors. So if you're going to return back an error code, it's very helpful to go ahead and throw a URL to your docs with that error in there. So instead of the user getting that error code and having to look it up in your docs and losing 10 minutes of their life to that, just return back the URL right in there with the error. And that goes to them and try to complete the API, they get an error, they can just throw that link up and they can see exactly what they need. Let's go through authentication. And this will really breeze over because OAuth 2 can take the whole presentation on its own. One big question is the consumer internal or external? Is it a user or is it yourself? So in this case, OAuth does a client-server communication for a user. That means usually someone on their browser getting your API, an actual user of the software, not necessarily another dev shop or anything like that. An actual person at their laptop, right? We're going to transfer a request token and get back an access token. And then that tells us, hey, this is the person making the request. We're going to check their credentials, see if they're authorized, whatever. And pass back an access token for them to use the duration of their session. It's up to you on how you want to expire that, right? But you know that they're valid because they pass through that access token. OAuth 2 is the current accepted standard. And when I say accepted, I mean it's what most people are using right now. That's what I recommend for auth in your API. It has many workflows. It's a really complicated spec. Surprisingly, it's easier than OAuth 1 in a lot of ways, but it's also not as worked out, especially with tutorials you'll see. I'll give you some resources at the end. If you want to learn more, find some good guides to it. The flow we'll talk about here is just a pretty basic client-server form. So you can send a request with the access token. The access token in this case could be server key plus client key, whatever you want to define for that access token. And then you're going to return that back. And that sends throughout the session, you just want to verify that. I'm making it sound really simple, but when you really dig into it, it can get pretty complicated because there's a lot of state you have to worry about constructing those access tokens, verifying them, things like that. That's something we can definitely talk about more later. I'll be outside a little bit. I'm going to dig into that. In this case, it's just an example of how you create a hash for the access token SHA to be encrypted. It really doesn't matter as long as it's a unique hash. It's a very short time use hash. rate limiting your API means that someone just immediately can't DDoS you. It also means that an error by one of your clients, say it throws it into a loop, doesn't bring down your API. Right? The way you do this depends on your setup. So maybe you do it on client key, maybe you don't have access tokens, maybe you do it by IP, or all of the above. You just need some way to say this one user of the API, or this one API key that I've authorized, is hitting me too much too often. Usually you want to limit that by request per second or request per minute, something like that. Maybe you allow 1,000 requests per second unless they upgrade and they pay more money and then they get 10,000 requests a second. You still want to limit it somewhere. And then it's a good selling point for you. Make more money that way. And also protect your servers, protect your app from going down. Debugging an API can be kind of weird because you don't necessarily have a console that you run this in. You're not necessarily in a browser. A few ways to do this is curl and command line. It's an invaluable tool for you to use. Just run the curl request and you can immediately see the response. Very cool. Super real time. Another idea is automated test. Definitely recommend writing tests for your API. You can do that with PHP Unit using curl or whatever. You can also use like run scope as a service I highly recommend. It lets you build your test cases out. You know, automatically run them. You can do regression testing for you. Run them every 5 minutes or whatever until your API goes down. Break your API at some point. It's also great for integration testing. So let's say you set up integration with a client's API, and that API goes down. You want to know that before your users, before your client is right? So you want some kind of automated message that it's gone down. Another idea is if you do continuous integration, every time you push up to your API, you can run tests against it and make sure it's still up. Jenkins or really want to use there. Also, for your own personal development, Rested is a client I really recommend on OS. It's just a nice, real simple GUI or GUI where you can set up your API, set up your params, your headers, things like that. You can save them and then just keep running the test locally, see what comes back. All right, I got through that fast. Go make cool things. Let's go through some resources. Build APIs you won't hate is a book by Phil Sturgeon, who I mentioned earlier. Demystifying REST is a very nice tutorial that breaks this down pretty easily. For OAuth, this is definitely going to be a rabbit hole that you'll go down. I really recommend OAuth 2 Simplified. It doesn't go through all the workflows, but it goes through the main ones you'll use. And then OAuth Hello is a book that Alex Bilby is writing, but I don't believe it's done yet. It could be by now. It's definitely worth checking out either way. I think it's on pretty well. My book, Building Secure PHP Apps, is $3 off if you use Openwest coupon code. It's just build secure PHP apps and then keep on it's Openwest. And we have about 7 minutes for Q&A. Also, if you go and join in and rate this talk, I would highly appreciate it. Just throw up that URL. It's 143 if you use the shortcode. And then let me know how I did. Give me some stars. Don't give me any stars. Give me feedback though. It helps me to know what I'm doing right, what I'm doing wrong, what I can cover more. Also helps the organizers to know which topics are appreciated most. All right, questions? Go.
Do you have any recommendations for someone who's looking to implement throttling on their REST API?
I usually do it custom. I don't know the new packages because it's usually a pretty custom thing. You can totally do it in your OAuth setup or how you're doing auth now. So let's say you're doing OAuth with like access token. You just add it there and say you say this access token is good for this many X requests. Or you can do it when you're getting out access tokens. So let's say you have like clients. That's not necessarily the user though. So you have this company A is authorized to hit the API 1,000 times. Whenever you put out those access tokens, you can match with that. And just add your throttling there. So based on that company, right? Based on what plan they're on. It's usually fairly custom, but it's usually super quick to get done. So you'll just log that to a database or Redis or whatever, and track it in the short term, and then stop it. Next.
Is there any special considerations you should make in your API concerning caching?
It depends on your use case, and it depends on how dynamic your data is. So the data is not very dynamic. You totally add a caching layer on top. Also depends on what kind of query you're doing. Most APIs, you're not really going to need it because the queries aren't that complex. You're not doing 4,000 joins or whatever. It's pretty advanced, we don't have to add workers to it. That's a great thing to just have like a callback URL in the API as well. So when this job is done, call back. That makes
So
sense.
saying for the most part, don't.
I'm not saying don't cache, I'm just saying it's a custom implementation, and I wouldn't worry about that at the start. So that's kind of something optimized for later.
What about like browser caching and stuff? Does it happen automatically?
The browsers don't usually cache the JSON responses. It also depends on your not your set headers, but your cache expire headers. So I usually set cache expires to no expire on the data, but again, it depends on how often your data changes. If the data's only once a day, just go ahead and set your cache expires for 1 day. So the browser will honor that.
Okay.
Next.
So what's the best way, so let's say you're looking at users, and maybe you want to report about, how many times have these users logged in a month, or this month. What's the best way in your API? Should you create a whole new resource, or should you have like a flag that you send over to say, I want that report, list all the users plus this data?
Part of that depends on how often you run the report. So if you want to keep it with a normal form, or if you want to break that out into its own table, I would recommend definitely at least a relational table saying this user won login since the date time. Which is, if you're running audits like that, you probably wouldn't have the date and time that they did it, if they had any failed attempts, things like that. So I would definitely recommend like a relational table. Then based on the performance you can report how often you're running it, you can take all that data, send it in a relational table, go ahead and pull in all the data in one table, look at run the reports. And that's kind of the thing of, do you want to keep it normalized or do you want it fast?
Okay, so it should just kind of line up to the database, is what you're
Yeah,
saying?
yeah, usually line up to the database.
So if I created a, what's that called, materialized view,
Mhm.
then match that materialized view, but if it's not common enough to do that, it should just kind of match.
Yeah.
You can do it the other way, okay?
Yeah, that makes sense. I usually try to keep my data models pretty close to the actual data that you're hitting. One thing to look at in PHP is Fractal, which is done by the PHP lead. And it's a library for kind of abstracting out where your database fields map to the actual output. 'Cause you don't want to do like a select star and throw that data out there. You don't want to expose your column names. Usually they won't be good for users of your API. But you just want some kind of layer to kind of translate that back and forth each way. But I usually try to closely map to the data layer. 'Cause that's really what you're trying to expose. Anybody else? All right, I'll be around. If you have any questions, wants to dive deeper, any specific use cases, I'd be glad to look at it. Thanks for coming. Appreciate it.